some point, and it actually happens relatively soon, you're paying more in power than you have for the machine. So, in terms of power that these are drawing, I'm not entirely sure. That's not something that I've looked at. Something that can definitely be figured out.
Can we blow a fuse?
We haven't blown a fuse yet.
Yep.
Look, here's the thing. These CUDA cards are low power. They're not.
They're less than 65 watt.
Yeah. So we're not. I mean, it's not.
That's for the whole card with all 100 processors.
Yeah, that's for the card running full tilt. So power is not in terms of heat in this room in the summer. Sometimes it gets hot, but I mean, we were running the cluster all night for the last 4 or 5 weeks or so. Nobody seemed to even notice in the morning.
We haven't turned the heater on in the building.
No, well, if you heat the building, then obviously it's going to get warm, but that's not the computer's fault.
I mean, no, the computers have actually saved us turning on the boiler.
Jen, you made a comment to me, this is kind of along the same line. You made a comment to me that you wouldn't want to actually use these cards in learning about CUDA.
No, because these cards are compute capability 1.3, and I know compute capability just seems like some random term that I'm throwing out there. But NVIDIA classifies their cards, and CUDA is being developed so rapidly that older cards can't keep up. Like, it is an extremely evolving technology right now. So these cards, the GT330s, can at most use the library's functions that were available in CUDA 1.3, which is actually old CUDA at this point already. You have, when I was writing code for these, I had to write code in an old style, which is one of the reasons why it was so difficult. I had to go back and figure out what these cards can do. Cards now can use, I mean, simple things like double precision.
Yeah.
These cards are only capable of doing single precision floating point calculations. So if I were in a class on CUDA, if I were going to go into the field and work for, a company that wanted me to do CUDA work, I mean, I could do that having learned on these cards, but there would be a lot of CUDA that I've missed because they're up to 4.1 right now. The highest we can go is 1.3. So it's definitely something that we need to consider.
How fast are we talking? Like, when did we get these graphics cards?
Yeah. We got these graphics cards last summer.
2010.
When we got them, they were already low middle of the pack.
Yeah, they weren't the $400 cards.
Yeah.
So what in a range of video cards is this kind of on the low end of?
In terms of CUDA cards, this is like 1.5 generation. Like the first generation of cards, this is not quite the second generation of cards. The 330s came out just before the second generation.
Did you get a maximum gigaflop ratio for the card? I don't remember.
For an individual card, 36 gigaflops.
Because I'm looking at one now, so we'll do a teraflop.
Oh yeah, the Tesla cards. Are you looking at the 2070 or the 2090? Some of I think the 2090 can get up to 1.3 teraflops, which is substantially more than this thing in terms of CPU.
Do you think that you and your advisor could put together a lab for 204 as an introduction to what you're talking about here?
No.
CUDA and Java?
CUDA is C-based, and it's very pointer driven. So this is definitely a 245 topic, and I'd be willing to do that, but a 204 student, absolutely not.
What's the pointer?
I mean, somebody who's just now figuring out how to light an array list doesn't need to know about it.
Most arrays of pointers, right?
Yes, arrays of pointers.
Arrays of pointers.
Yeah. So
They put it together, but they do.
you know, questions there? Yeah. Okay. Well, after this was all done, Dr. Pons and I presented posters to the Society for Industrial and Applied Mathematics parallel processing conference in Savannah, which was something that I think is kind of unique for me as a student to go and actually see in an international conference and talk to people who frequent international conferences and kind of see where the field is at. And Dr. Khan's made a comment to me that the more I look at it, the more I agree. You know, you learn the basics of something in class, and then you go home and you buy a book and you learn what's been done and how to do it. And then once you've started to learn a topic in a book, you start to look at papers. And papers let you see kind of what's going on, what has just happened. But if you really want to look at the bleeding edge of a field, you have to go to these conferences. And it was an amazing experience because I got to see things that I had never seen before. I got to start to understand and look at code in a way that people in laboratories now are starting to do. You know, the forefront of developing algorithms, looking at exascale computing, things like that. Ways of taking your algorithms and removing communication as much as possible. All these really important ideas that could revolutionize the way that we do scientific computing, and seeing how they're being developed right now. And so I think that for all students, not just myself, it would be important to see something like that, because up until now, I mean, I have an idea of what's going on in the field, but I really don't know what I'm walking into when I graduate. And I feel like I know that now. I know what I could be looking at, where I could be going, and I think that that's important. I brought the program guide, and this is the schedule and the abstracts for all the presentations. They fit all this into 3 days. So there's a lot of information that's going around.
Started at 8 a.m.
Started at 8 a.m. every morning, didn't end until usually 9 o'clock at night, and it's just all day. Graduate students and professors and laboratory people talking about their work. Everything from, you know, cryptography to tracking the movements of our entire universe, all in one place, and how they're going about calculating these things. It's very impressive. It also helped me being able to talk to these people who are way smarter than me, trying to grill me on what I've been doing, and kind of helping me solidify what I know and what I don't know, and what I need to be learning in order to be proficient. So that was very beneficial for me. I don't know, you know, for presenting research in the future, and also for job interviews, things like that. So it was very cool.
Was anybody hiring?
I didn't see a whole lot of companies there that were recruiting. I saw plenty of people with logos on their shirts. You know, NVIDIA engineers, IBM engineers.
Well, there's an interesting ethical issue about people who hire at conferences like this, because they're usually interviewing people who are being paid for by another company.
Mm-hmm.
You know, it's like,
Well,
if
I'll
I
say
go to
that-
an academic conference and somebody says, "Hey, we want to hire you," Mercer's paying my way to find another job.
I will say that this conference was much more academic than it was
We
in
saw
terms of jobs. It was. Let me put it this way: these people came out of their labs to go to the conference, and they were excited to go back to their lab. And there weren't any more people. It was very academic.
I think the term is nerd central.
Yeah, it was done right nerdy.
You mad at that guy?
But we did see, I mean, you saw some talks, and you saw what happens when people aren't really prepared for a talk, too.
Oh yeah, yeah. You definitely shouldn't take something like this lightly. If you're going to go to a conference and you're going to try and talk to people who do this for a living, you need to be prepared for what you're going to say. You need to be sure that you know your material well enough to think quickly through something they're going to say. And we saw that, unfortunately, for a graduate student who just wasn't able to think fast enough, and it was awful. But yeah, it's amazing what these people know and how well you need to know your material to be effective there. Any questions about the conference?
You see any boats?
Yeah. At all hours.
Big boats, little boats?
Yeah. All of the boats. We actually, where we were staying was right on the river where all of the big container ships go by. So at 2 o'clock in the morning, you hear a horn from a boat, you know, the size of this campus right outside your window. You'll wake up.
Yeah. They're great accommodations, though. Can't complain.
Oh yeah, it was fantastic.
Soundproof the rooms a little bit. Soundproof the rooms a little bit.
Well, one wall was entirely glass. You can't soundproof glass.
You can't complain if there's a balcony that opens onto the river.
I'm not complaining. I'm not
It's really
complaining
nice.
at all. Just saying, that boat scared the crap out of me. Well, that is my research, and that is the Scion parallel processing